Hello and welcome. We're returning into further maths, and we got a vector question which I put into one of my FP1 papers that I uploaded. I think this question is already up there, but I can't remember the paper. I don't think it's one of the harder papers. I think it's I.J.K. or one of these papers. So unfortunately, when I printed the question, the front has been cropped. All it says is this system of equations is given, and then he's asking us to do things. So it's got a part A, part B, and a part C. So we're going to do it step at a time. I copied the equations down before the video, so I just want to check that they're copied correctly. 534, 162, 62 minus 9, 9, 8, 75. They're all correct. And how do we solve equations like this? Well, a lot of people haven't really often seen questions like that, or three equations, three unknowns, until they get to A level. And I can assure you they're very straightforward. When I was a student myself, I'd done this in year 9. The extension, after we'd done 2 equations, 2 unknowns, we proceeded with 3 equations, 3 unknowns. And if one of us was particularly good, then the teachers gave us some more punishment, 4 equations and 4 unknowns. The method is just exactly the same. And at that level, you just use substitutions, really. You don't go for eliminations or row reductions or anything like that. So I'm going to look at the coefficients. There's a y there on its own. So I'm going to say y is equal to 9 minus 5x minus 5z. And I'm going to substitute this y into the other 2 equations. 3x plus 6 lots of y. And it's very easy to make mistakes on this. Yes, it is actually tedious, but all it takes, and it can be kind of like if you make a mistake, it can cost you more time than going slowly and recording from the beginning all the workings. 2y minus 9z is equal to 75. So we move to the next line. 3x plus 54 minus 30x minus 36z plus 2z is equal to 8, and then 4x plus 18 minus 10x minus 12z minus 9z is equal to 75. Collecting terms now. What do we have in there? Oh my god, a very big numbers there. What have I got? I've got there 23x minus 27x. That's the first bit. That's x, and that's x. I got z's there, so minus 34z, and the numbers now is negative as well, so it's going to be minus 46. X is minus 6x. The y's are going to be minus 21z. I don't like these numbers at all. And 75, the 75, take away 20, 55, add 2 is 57. Okay, the first equation is just a mess. The second equation is divides by 3, but it will hardly matter. So what I'm going to do, I can get the 6 into a 27, and I'm going to also multiply this by divide by 2, and multiply, that'll give me a 3, and multiply by 9, but this doesn't half, it's just a mess, sorry. I'm going to eliminate this x's, so I'm going to go, this one is going to be times 2, this one is times 9, that's 54, that's 54, and one of them will be a plus or a minus, it doesn't really matter, I'll leave it as a plus as both of them, and I'll subtract. Minus 54x minus 68z is equal to minus 92 times 9 minus 54x 921 180 189 189z, and 57 times 9 is 450. 9 times 50, 7 times 9 is 63. I'll make it equal to negative, why negative? I'm mistaken, isn't it? Yeah, there is no mistake. 75. No, it's not negative. It's 75 take away 18 is 57, and 57 times 9 is 513. Okay, and now we can subtract the equations. I'm going to subtract that minus that is going to give me 189 take away 68, 6 from 21, so I've got 121, lots of z positive, that minus that, and if I subtract that, I'm going to get 92, and 513, I'm going to get 50605. That minus that is a negative, minus 605, and z is indeed minus 5. 5 lots of 120 is 600, and 5 lots of 1 is 5. And I think somewhere there was a show that z is equal to minus 5 and find the values of x and y. So z is equal to minus 5. And the x, which equation is probably the best to use from here, is the equation that says minus 6x minus 21z is equal to 57, minus 6x, 5 lots of that negative, so it's going to go plus 105 is equal to 57, and that's going to be a positive 6x on this side. From 57 go 43, and 5 is 48, so x is equal to 8. So let's put these bits in there. X is equal to 8, and the y is, of course, y is 9 minus 5 lots of x, which is 40, and 6 lots of z negative, which is going to be plus 30. So y will be equal to, in this particular case, minus 1. 39 take away 40 minus 1. Okay. What I'm going to do, I'm going to, because I want to need the board, and I don't think this is done just randomly. Z is equal to negative 5, x, what's wrong with it? X is equal to 8, and y is equal to minus 1. These are my solutions, because there's a good chance I'm going to need it later. Okay. Later we're going into vectors, so let me just clear the board and I'll let you read the rest of the question. You don't actually need, there's a way, in my solution I did use several methods later on, alternatives if you prefer the word, where this first part becomes obsolete, but of course there is a way of doing this where the first part is very useful and does the question very quickly. Okay, what does it say next? The straight line L and the plane capital pi have respective vector equations. That's your line R1, point on the line plus parameter times direction vector, and the plane is fixed point on the plane plus parameter times a vector on the plane plus another parameter, another vector on the plane, where these two planes are not, sorry, these two directions, if you want, they're not parallel. Okay, show that L, the line L, is perpendicular to your plane. How many marks is that, or should that be? Okay, this is for further maths now. It's just a lot of tedious work. Maybe 4 or 5 generous marks is okay. 5 is generous and is good. Show that L is perpendicular to the plane. I mean, how many marks for that? Maybe something like 5 marks. Let's record the line. R1 is minus 29 minus 946. Again, I apologize, I'm writing in rows as opposed to downwards in columns. -6, -2, 9. In the plane, I'm going to put the information into a picture so we can all see what's going on, because this plane is in parametric. I'm going to label maybe some of this into the picture. This is the point with coordinates -38, quite ugly, which is on the plane. This is the origin somewhere. And then we have two vectors on the plane. These are not position vectors. I can find what's there, but one of them is 534, that's this direction, and the other one is 162, that's the other direction. And if we look at what we are trying to do here, where's my lid for this particular pen? Oh, I've lost my lid. It's really enough to make me very, very angry. I hate that. Okay, I'll try to use a red pen. No, there's a red pen. And if we cross these two particular vectors, we can get a perpendicular, mutually perpendicular, which is going to be a normal to the plane. So the next thing to do is to do, of course, a quick cross product. So I.G.B 5, 3, 4, 1, 6, 2. I component is 6, take away 24. So that's going to be a -18. And then this I'm going to do backwards because it's going to be a -1. So it's going to be a 4, take away 10, which is a -6. And lastly, the k goes the normal way. 30, take away 3, which is, of course, a +27. And if you look what happens here, this can be scaled to, I can factorize out looking at the direction of the line, they need the minus to be inside, so it doesn't matter. Pull a 3 out, -6, -2, 9, which still does, in other words, it can be scaled to 6, -2, sorry, -6, -2, 9, which is the line direction, which of course, what does that mean? It means the line and this normal have the same direction. Indeed, L parallel to capital Pi. So this is the second part done. How many marks for that? There's no marks, unfortunately, for drawing the picture. The picture is obviously very, very useful, and I will always draw things to see what's going on. Something for the cross product, probably something like 3 marks for this, unfortunately. Candidate does the cross product correctly, scales and concludes, and that is it, basically. For this particular question, I will do it in one way, although I'm showing alternatives for the part C now. It says, show further that the line meets pi at the point with its coordinates. So the line doesn't necessarily passes through this point here. Of course, there's infinite normals on the plane. Your line could be going like this, coming out of there, of course in the same direction as a normal, and we need to find the coordinates of this point, and it will turn out to be -911. Okay, where do we go with something like this? I will rewrite this, clear the board first of all, and this is where the part A, I will do it with a method that the part A comes in and makes life very, very easy, if you see it. And this is what happens. If you look at the equation of the line, I'm going to write it in parametric. So x y, z, the coordinates x, y, z. I don't know if it's visible to the viewers when what I'm doing in there. It's going to be minus 29 minus 60, minus 9 minus 2t, and 46 plus 9t. This is the line. The plane, the coordinates of any point on the plane, x, y, z, that's the vector r2, is going to be equal to, in parametric again, this has two parameters in, so surfaces have two parameters, minus 38, minus 17, minus 29, plus 5 lambda, plus 3 lambda, plus 4 lambda, and then we got plus, a mu, a 6 mu, and a 2 mu. So all I've done is I've just written these two equations more compactly. And of course, if you try to find where these two objects meet, you will solve the equation simultaneously. So this x, y, and z of the line must match the x, y, and z from this plane. So what we will have in here, shall we put the plane first? It doesn't really matter. Let's put the plane first since it has more stuff here. 5 lambda. What am I doing? It's because I'm thinking ahead of myself, so forgive me for that. Okay, actually I don't need. I'm gonna drop the matrices there. Actually, not matrices, vectors. It's actually what it is there, but vectors are matrices. That bit here is equal to minus 29 minus 60. The y component, minus 17 plus 3 lambda plus 6 mu, is equal to minus 9 minus 2t. And lastly, looks very, very messy, doesn't it? It's kind of scary what I want to do with this, but there is a better way of doing this, but it doesn't use part A, which I am showing in my workings, but this uses part A, and you will see in a minute. I'm gonna just unfold this, and hopefully you can see what's going on. Look at this 5x plus y plus 6z. 5 lambda plus mu, bring the t bits to the left, plus 6t, minus 29 add 38 is equal to positive 9. And then 3 lambda, 362, plus 6 mu, move that to make it plus 2, and then hopefully this will match. It's going to go plus 17, so in fact it is equal to 8. And lastly, 4, 2, minus 9t, and this is going to be a very big number because it's going to go positive. Call it 30, 76, take away 1, 75. Now, if you look at the system of equations, we kind of have some kind of equivalence. I just have to know which letter is which. So what do we have in there? We have the the x is your lambda, your mu is your y, and your t is your z. So in fact, we know what these numbers are. It hardly matters whether we call it x, y, z or lambda, mu, and t. And we did write them down. The z was minus 5, so the t is equal to minus 5. The mu was equal to 8. And the lambda, which was the x, sorry, I've made a mistake there. Yeah, I did make a mistake. I do apologize. The mu, which is your y, was minus 1. And the x was, in fact, your lambda, which was 8. How does that help us? Well, very, very simple. We can go probably to the equation of the line, and the line only requires t is equal to minus 5. But of course, you can take the lambda and the mu and go to the plane. You'll get the same coordinates. And in fact, it's good check at the end as to make sure you got the right things. And of course, your x, y, z is going to be equal to minus 29, minus 9, and 46. And we're using minus 5, so that's going to be plus 30, in the, sorry, is it plus 30? Yep, okay, plus 30, and then we've got minus 9, and the t is minus 5, so it's going to be minus 9 plus 10, and the 46, 9 lots of 5 is going to give us sorry, negative there, so there's going to be t negative 5, 46 minus 45, so it's going to give us the coordinates 1, 1, and 1, and it appears there's a mistake in, well, I hope it's not in the video that I'm doing now. I hope it's, because I have to record it. It says show that the line L meets at the point minus 9, 1, 1. So I don't know what I've done in this particular case to give me this atrocious numbers. Quite clearly a mistake somewhere. I'll make it 1, 1, 1, by the way, while on my paper, my solution and everything else, I've got very different answers, so I hope I haven't made a mistake in there. Anyway, on this note, I hope you followed this particular question. It's not a difficult question. It's all staple diet from further maths and vectors. I hope you enjoyed it, and I will check with my paper right now after this video what's going on, whether this should be a minus 9 for the x coordinate. I've got 3 1s in there. Okay, I will see you very soon. I'm signing out. Bye for now.